So in this video we're going to talk about how to do linear regression using the graphing calculator, and we're also going to review how to write linear functions using data points. And we're going to discuss specific vocabulary dealing with our regression models and lines of best fit. So get right into exercise 1. We're talking about a pediatrician that is seeing if there's a relationship between an infant female and their weight and the age of 100 babies. So going through parts A and B, they want us to use a ruler to draw a line that you think best fits this data. So what the goal is with this, and again, I'm not going to actually get a ruler on the screen, but you want to try to draw a line that goes through some of the points as best you can draw it. Okay, so something along those lines. And then it says for part B, pick 2 points that are on the line. So I'm going to use these 2 points. That one seems to be touching this one as well. And what we're going to do is determine the equation for that best fit line. So we're going to do this one by hand, and then we're going to do one with the calculator. And you'll see how they're pretty close, if not exact. So we picked, in this case, I picked 3, 12.2. And the other point I picked is 9, 19.4. Now, we're going to do rate of change to see how quickly this is rising. So if we subtract each side, if I do 9 minus 3, I get 6. 19.4 minus 12.2, I get 7.2. So if I do 7.2 divided by 6, I end up getting 1.2. And that's going to be the slope value. The next part I'm going to do is I'm going to take my equation of a line we discussed in Unit 3. Well, I now have a slope of 1.2, and I'm going to use one of my data points. I'm going to use the first one. I'll use 3 and 12.2. So I plugged in my slope, and I plugged in my x and y values that I decided to use, which I decided to use this one. Now I'm going to go ahead and distribute, try to get y by itself so I get an equation. So with that distributing, I get 1.2x minus 3.6. And then, to finish off, I'm going to have to add 12.2 to both sides. So I'll end up with y equals 1.2x. And then we got negative 3.6 plus 12.2. And just be careful when you put that in the calculator, because you're going to end up with values that, if you don't do a negative and positive, won't be correct. So we end up with 8.6, and that would be our equation for our line of best fit using a couple of data points. And again, depending on what points you use, this is going to vary. This could be close, but it's going to vary a little bit. It's not going to be exact. Now, if we go down to parts C and D, I'm going to leave that equation that we had for the first part, but I'm going to erase the work. And we're going to talk about how to use the regression command in the calculator. So if you go to your calculator, what we're going to do is we're going to put in, I'm going to leave that there, we're going to put in the numbers from the table. So if you do stat and enter on edit, then you can put in your age values, and you can put in your weight values. So that's what I'm going to do right now. And one thing you really want to look for as I'm putting these in is just make sure when you get done with your list, there are the same amount of x and y values in L1 and L2. So you notice I got 6 in each. Then to get the equation, I go to stat and calc, and then I pick option 4 because it says linear. So here's my, for this one, here's my equation. So what you want to do is you want to round it, like we talked about before. It said nearest tenth in the top one. We're going to go ahead and we're going to write in A and B. So A to the nearest tenth will be 1.2. x, and b is 7.82, so it's 7.8. And again, you'll see that this is pretty close to that. Looks like the y-intercept is slightly off, but our slope was actually the same. And then for part D, it's talking about the correlation coefficient. Now, to get the correlation coefficient on the calculator, you have to press second and 0 to get the catalog. And then if you go down to D, you have to choose diagnostic on. So after you do that, you can pull up by hitting second enter a couple times. You'll see that R will pop up. They want us to round this to the nearest thousandth. Remember, when you're rounding, especially thousandths, 1,000 has 3 zeros in it, so that means you need 3 numbers past the decimal point. So in this case, this would be 0.995, and there's a 2 past the 5, so for this one, 0.995 will be the correct answer. We'll want to bump that 5 up because of the 2. So that's our correlation coefficient, and in this case, if that's close to 1, there's a strong relationship between those two values. So we have a really strong relationship between the age of an infant female and the weight that they are. So that doesn't really vary too much. It's pretty close, if not almost an exact perfect line. Now we're going to move on to another example, and we're actually going to use the equations that we just found for exercises 2 and 3, and we're going to use the one that we did for the in the calculator. So I'm going to erase the first one. We're going to use the 1.2x plus 7.8. The goal with exercises 2 and 3 are just to help us make predictions based on this model. Sometimes they refer to the equation as a model because that model is based on the data that was given to us. So for exercise 2, they want us to figure out the predicted weight of a girl after 10 months. And going back to that table, you'll notice it said that, okay, the age, the months, that was our first column. That was our x values. So we're going to take the 10, and we're going to put that 10 in where x is. And the other way you can do it, and I'll show you both ways, you can calculate this. Just throw it in the calculator. So there's 2 ways you can find the answer. You can find it by typing it in with the numbers substituted. That'll give you that specific value. So in this case, we got 19.8. It says round to the nearest tenth of a pound, so 19.8 it is. 19.8 pounds. The other way you can find it is if you take your model, put the model into the calculator, and then go to the table at 10, you'll see that answer of 19.8. And besides that one answer, you'll see every answer for every month as a prediction. Now, if we're doing exercise 3, this one asks us to find the weight after 2 years. So if you go past 10, 2 years would be 24 months. Well, based on this, it looks like our answer would be 36.6 pounds for a 2-year-old on average. And now the difference with these 2 answers is that the first one, they call it an interpolation because that number is actually in the midst of the table. So 10 is in between 9 and 12. Whereas for exercise 3, 24 months is not on the table. And what can happen sometimes if you get away from that table, the farther you get away, the less likely the prediction is to actually be true. So for example, let's say you wanted to check what the weight would be of someone that's, let's say, 40 years old. So this is just a hypothetical situation. Well, 40 years old would be 480 months. And I'll use the calculator right now to show you that if you were to take that same equation and you plug in 480, this relationship won't hold because that would end up being the weight of an average 40-year-old woman, which is obviously a lot higher than you would expect. So when you are using models to make predictions, it's always better and more likely to happen if it's within the data that's given to you. And if you get numbers that are farther away, kind of like the example right here, the one we're doing right here, the predictions become less and less likely to be correct.